When installing a generator transfer switch, whether or not you need a separate service disconnect depends on whether the main breaker in your existing panel is rated for the amperage of the generator you are installing. If the main breaker is properly rated, you can utilize it as the service disconnect for the generator system. Let's delve into this in more detail. Firstly, let's discuss the purpose of a service disconnect. The service disconnect is the main point at which electrical power can be isolated from the premises wiring system. This is essential for safety during maintenance, repairs, or in emergency situations. It allows you to completely cut off the electrical supply to the building, ensuring that no live electricity is flowing through the system. In a typical residential or commercial electrical system, the main breaker in the main electrical panel serves as the service disconnect. It is usually a large breaker located at the top of the panel and is rated to handle the full load of the electrical service coming into the building. Now, when you introduce a generator and a transfer switch into the equation, the function of the service disconnect becomes even more critical. The transfer switch allows you to switch between the utility power and the generator power, ensuring that the generator's power does not backfeed into the utility grid, which could be extremely dangerous for utility workers. The transfer switch also isolates the generator from the utility when utility power is present, preventing damage to the generator. The key consideration here is the amperage rating of the main breaker in your panel and the amperage output of the generator. If the generator is capable of producing more current than the main breaker is rated to handle, then you must have a separate service disconnect to protect the system. This is because if the generator were to overload the main breaker, it could potentially damage the breaker, the panel, or the wiring in the building, and could even cause a fire. Let's consider a scenario where your main panel breaker is rated for 200 amps. If you install a generator that is capable of producing, say, 100 amps, then the main breaker can indeed serve as the service disconnect. If, however, you install a generator that can produce 250 amps, you would need a separate service disconnect, as the 200 amp main breaker would not be sufficient to protect the system from an overload. The generator cannot exceed the electrical panel's rating or it will cause the main breaker to trip. Exceeding the electrical panel's ampacity will create hazardous situations. Here is what to consider when determining whether to use the main breaker as the service disconnect or to install a separate one. Firstly, determine the maximum amperage output of the generator. This information is typically found on the generator's nameplate or in its specifications. Secondly, check the amperage rating of the main breaker in your electrical panel. This is clearly marked on the breaker itself. Thirdly, compare the two amperage ratings. If the generator's amperage output is equal to or less than the main breaker's amperage rating, you can generally use the main breaker as the service disconnect. If the generator's amperage output is greater than the main breaker's amperage rating, you will need to install a separate service disconnect. It's important to note that there are different types of transfer switches, and some of them may have built-in service disconnect features. For example, some automatic transfer switches ATS come with an integrated service entrance rated disconnect. These types of transfer switches are designed to provide both the transfer function and the service disconnect function in a single unit. If you use one of these types of transfer switches, you may not need a separate service disconnect. It is important to consult the manufacturer's specifications and installation instructions to determine whether the transfer switch provides adequate service disconnect functionality. There are several key code sections that dictate how the generators and transfer switches must be installed safely and in compliance with the electrical code. It's essential to be familiar with these requirements to ensure the safety and proper functioning of the generator system. Article 700, Article 701, Article 702, and Article 705 of the National Electrical Code cover emergency systems, legally required standby systems, optional standby systems, and interconnected power production sources respectively. These articles provide detailed requirements for the installation, wiring, and protection of generator systems. Some specific requirements addressed in these articles are as follows: wiring methods, which specifies the acceptable wiring methods for connecting the generator to the electrical system and the transfer switch to the electrical panel. Overcurrent protection specifies the type and size of overcurrent protection devices such as breakers and fuses required for the generator and its associated circuits. Grounding and bonding requires the proper grounding and bonding of the generator and the transfer switch to ensure electrical safety. Transfer equipment specifies the requirements for the transfer switch, including its rating, construction, and operation. It is always recommended that you consult with a qualified electrician who is familiar with local codes and regulations. They can assess your specific situation, determine the appropriate size and type of transfer switch and disconnect, and ensure that the installation is done safely and in compliance with all applicable requirements. In addition to the amperage considerations, there are other important factors to keep in mind when installing a generator transfer switch. Firstly, make sure that the transfer switch is properly rated for the voltage and current of your electrical system. Using an incorrectly rated transfer switch can be dangerous and can damage your equipment. Secondly, ensure that the transfer switch is installed in a location that is easily accessible for maintenance and repairs. The location should also be protected from the elements and from physical damage. Thirdly, follow the manufacturer's instructions carefully when installing the transfer switch. Incorrect installation can lead to malfunctions or even electrical hazards. Fourthly, always test the transfer switch after installation to ensure that it is functioning properly. This includes verifying that the transfer switch switches between the utility power and the generator power correctly and that all safety features are working as intended. Fifthly, regularly maintain the transfer switch and the generator to ensure that they are in good working order. This includes inspecting the wiring, cleaning the contacts, and testing the batteries. When determining whether a separate service disconnect is needed for generator transfer switch installation, consider the following common mistakes. Firstly, ignoring the generator's amperage output. It's crucial to know the maximum amperage that the generator can produce to ensure that the electrical system is adequately protected. Secondly, assuming that the main breaker is always sufficient. Just because the main breaker is rated for a certain amperage doesn't mean that it can handle the additional load of the generator. Thirdly, neglecting to consult with a qualified electrician. Electrical work can be dangerous, and it's always best to consult with a professional to ensure that the installation is done safely and correctly. Fourthly, failing to follow the manufacturer's instructions. The manufacturer's instructions provide specific guidance on how to install and operate the transfer switch and generator, and it's important to follow these instructions carefully. Here are some additional considerations. Firstly, consider the type of loads that will be powered by the generator. If you plan to power large appliances, such as air conditioners or electric water heaters, you will need a generator and a transfer switch that are capable of handling the additional load. Secondly, consider the frequency of power outages in your area. If you experience frequent power outages, you may want to invest in an automatic transfer switch that will automatically switch to generator power when the utility power goes out. Thirdly, consider the noise level of the generator. Generators can be quite noisy, so you may want to choose a model that is designed to be quieter. Fourthly, consider the fuel source for the generator. Generators can run on gasoline, propane, or natural gas, and each fuel source has its own advantages and disadvantages. Fifthly, consider the cost of the generator, the transfer switch, and the installation. The cost can vary widely depending on the size and type of equipment you choose. In summary, when installing a generator transfer switch, you can often utilize the main breaker on the panel as the service disconnect if it's properly rated for the generator's amperage. However, careful assessment of the generator's output, the main breaker's rating, and local electrical codes is crucial. When in doubt, consult with a qualified electrician to ensure a safe and compliant installation. This will ensure that your generator system operates reliably and safely, providing you with backup power when you need it most. Understanding the relationship between the generator's amperage and the panel's breaker is paramount for a safe and effective installation.